Hi everyone, welcome to another episode of Experiments in AI. So with our continued journey through Ollama, we're moving on to multimodal capabilities. So this is where the model that I'm going to be running has a multimodal modal capability. So we're going to be using Lava. You can use things like Llama 3.2 Vision as well, or anything like that. You can even try it with a model that maybe isn't multimodal and watch it perhaps break. This episode actually is the most fun I've had putting an episode together, simply because the amount of interesting error messages I got in trying to get this to work. So yeah, it's quite a fun thing. Suffice to say, it works great now. But yeah, it was quite fun just working my way through various request stuff. So, as I've mentioned in previous episodes, there's certain prerequisites you need for this, certain tool chain. So just going back very quickly, I'm running Anaconda, which as a part of its install gives me what I need. And the main parts you need for this is Python and Jupyter Notebooks. You will also need Ollama downloaded, so obviously a local copy of Ollama because we're talking about Ollama. You might want to read the documentation, you might not. You will need the Ollama library installed with the usual techniques, either pip install it or conda install it or whatever method you use for your particular setup, silo, tool chain, whatever you want to call it. And you'll need some models. Now, as I've said previously in a lot of these episodes, I do have a pull function in the notebook, which will pull down the model if you don't have it. Not all of them have in there for various reasons. We've had one episode where it didn't. But yeah, I'll include it as necessary, really. But there's nothing to stop you pre-downloading these models, because we'll talk about the function in a moment. I've actually got two versions of this. I've got one I've run already, and then this one, and I'll explain why in a moment. There's a little bit of sort of custom information relevant to yourself you have to put in for usage reasons, which we'll get onto in a moment. Basically because we're using images from Wikipedia and they require certain headers in the request part. So we've got effectively two types of requests going on here. Maybe actually a third, I suppose. So our main requests in terms of, our experiments are going to be to Ollama. But for this illustration, for this experiment, I thought, one, we need to be able to try this, to do it with images on the web and also local images. So this does both, basically. Now, to achieve that, not only do we need the Llama library, we also need the request library and some sort of way of encoding the image so that it is agreeable to the large language model, that it can ingress it correctly. And then there's something to do with input-output as well, because we're playing around with local images and stuff like that. So yeah, there's a few things here that I think Bytes. Oh, actually, no. Is there a Bytes IO? I can't remember where that's used now, but it must be used somewhere in here. It is quite possible with some of these that. Oh no, there it is. Yeah. So there's another part of the library there. Another library that's used there. I was trying to remember where it's used. So it is used for the URL stuff. So some stuff here that needs to obviously be loaded. The good thing is these ones here are sort of, well, for me, were part of the batteries included element of my install. So I would be unusual that you would have to install these, but you never know. I don't know what sort of tool chain you're using. So yeah. But certainly, if you haven't installed Ollama before, then yeah, you'll need to install that library so you can then import it. So everything's been already either there or installed, so we can safely import these, no problem at all. Okay, we've got a pull function, as some of the previous episodes we've always had, where we just, call this pre-prepared this nice function, which is abstracted away all the messiness. So literally, we just do this. It reaches out to Ollama. This is all abstracted away, and checks to see if there is a model present with the name you're after. If there is, then as far as it's concerned, yep, the model's been pulled. I don't need to do anything else. If the model isn't there, then it will pull it. And that's all part of the functional abstraction. A little bit of error trapping there, nothing too complicated. Then we've got some encoding. So we've got to take these images from wherever they are and then encode them so we can then push them into the model along with the questions we're going to ask. So we have a function to do that for the image on the web, or images on the web. And this is where this personal info comes in. So in my version, I have some other stuff in here. And this is a requirement of Wikipedia. If you don't use it and try and do it without it, you'll get something like a 404 error, and it will actually say to you, oh, there's certain, I don't know, conditions of operation, I can't remember the exact terminology, that you need to abide by. And it involves inserting a header in, and then it will include a link which you can go to, and it describes what needs to go in there. So in my version, I have, the name of the particular application, and that can be a name that you just want to, whatever you want to call it. It's just for reference. So this might be a multimodal experiment, or Mav's multimodal experiment, or whoever, and then your email address. And that's so that if down the line there's a problem at Wikipedia's end, maybe you're messing around, something's causing a problem by you pulling the information out, they can get in touch with you. And as I've said, if you don't include a header as part of your requests, it will push back and you'll get an error, along with, like I say, some sort of return which explains the reason or what you've got to do. Then we get encode image from path, probably slightly simpler in that we're just looking at a local image here. So we've still got to do some encoding here, but looks like we haven't got to pass anything through any extra bits and pieces here. So yeah. Then the actual query for the multimodal model, which has the model name and the questions and the images going in there. So yeah. And then finally the experiment. So here's our model. We're going to pull the model, and if pull model works fine, and of course all of this, we've got some error trapping going on, so if there is a problem, we'll get some stuff back. It'll go ahead and first of all, we need to load up image sources. So you can see we've got two up here which are from the web. One's a JPEG, one's a PNG. Two down the bottom from the web. I think these are both JPEGs. And then two local JPEGs, one of which is considerably larger than the other. A series of questions we want to ask about each image. And then we're going to run the experiment. So we've got iterations inside iterations. So we're basically going through the image sources and one by one going through and asking the questions and getting an answer. And if there's an encoding failure, it will skip over it. And then just something to note when the experiment's finished, and some extra observations to make on your experiments. Because as we know, after we've done our experiment, we need to think about the results and to make observations on that. And then we've just got this else here of if for some reason our pull result is not true, then yeah, exiting due to a model pulling failure. Okay, so here's the results. Here's one I prepared earlier. So this does take, out of all the models I've gone through so far, or the setups, experiments I've gone through so far, this, I think, apart from possibly the first one, might take the longest to run, because of all the sort of, image recognition shenanigans. So you can see here's the questions. Describe the image. What objects are in the image? What text is in the image? What does it say if there is? What's the main subject? And what colours are prominent? And it does that for every single image. So first up, it says there's an image of a cat with its mouth wide open, and then it goes on to further describe the cat. So there we have, that's what the first image is. Second image, educational illustration, eye anatomy. So it's implying, and it's got various components that it's picked up in terms of objects. What are the subjects? Is there any text? It says there's text, it just says retina. And obviously when you experiment with different models, you may get the different levels of detail. The other thing is, if you try and do this with a model, and if I just go back, I didn't think I explained that too well on the previous one actually. You'll notice there's a section here where we're querying the multimodal model. I'll get there in the end. And you can see that if you've been looking at these in detail, there's probably something here that you might not have seen in previous examples where we've done a generate. And this is this images here. So we've got the question and the image we're passing in. So one interesting experiment to do is to see, what happens if maybe you try this with a non-multimodal model. What happens? So yeah. And I would probably, if you're going to do that, I'd probably just do it on local images initially, just to try it out, rather than get too tangled up in pulling stuff down from the web. But of course you can, play around with this by simply swapping out what's in there. It's that easy. And then changing the locations here, maybe commenting certain things out. Yeah, so. Okay. Yep, so eye, what is it? Yep, it's an image of an eye. Now, as I've said, on certain runs with certain models, you can do things like adjust. If you want to, you can go and adjust temperatures and various other things. Or, as we've looked at previous episodes, you can maybe even build your own model file and create a version of the model to adopt a more, adopt the persona of a art expert or something like that. So lots to think about, lots to play around with if you stack these episodes in certain ways. So test 1, adorned with books, a black cat sits comfortably on a grey cat tree, and it goes through what objects are in the picture, what text is in the picture, main subject, what colours. And also, of course, bear in mind that if you wanted to, you could just add extra questions to this experiment. Is it wearing a hat? That sort of stuff. And there we go. It's math. Okay. Number 2, graphic design with a sports theme. 2 dogs in the centre racing against each other. It says the text reads bloom. And park life. Now this is interesting. Okay, so now, this is good. So now it's actually identifying this as park life with blur. It does, and you'll see why I might have trouble identifying the text in here. The image relative to a lot of the other images here is quite low res, as is a lot of album covers on Wikipedia, which is where this originated from, but I've just stored it locally because it happened to be an image from a previous episode I'd done about, I think, albums from 1990s or something like that, so that's where that came from. But the origin originally, I think, was a Wikipedia article. And of course with these as well, we could have downloaded these and run them all locally and adjusted the these locations accordingly, however you want to do it. So there you go. And I've run this several times now, and yeah, sometimes it will get this right. It's getting this right, but yeah, sometimes it'll say something else here because it's having trouble with the blur bit. The blur bit's obviously a bit too blurry. Yeah. So the image description, it's got it wrong, but the objects, it's right, and the text is right, question is right. So that's interesting. Then we get this. Probably a bit of a giveaway here with that, if you're reading this. Image is a historical painting depicting a social interaction in what appears to be a formal setting, possibly a drawing room or a courtroom, and so on. Quite a lot of information about the elements of the picture, which is cool. And that is this one. Pretty famous painting. And then finally, whoops, we have this. Abstract composition, cubism or modern art. And again, as we ask it certain questions. So the good thing about this is as you use this, you'll start to uncover certain good questions to ask about images, which might narrow down information a bit for you. So, and out of all the experiments I've done, this is probably the most fun and the most challenging in terms of me sort of debugging certain aspects of it to get it to play nice with the web and pictures and encoding and various other things, because it's quite amusing is that sometimes when you were designing these, you can get them to run okay if the what was I going to say, if this is correct technically, like if it's structurally this is correct, but if you've made a mistake with the encoding, it'll hallucinate and come up with all sorts of things. Another interesting thing to do as well, if you're skeptical as to whether it's reading the, somehow knowing what this is, which I don't think there's any way of it actually working that out. You can just do what I did, download them and give them an abstract name. Doesn't really make any sense. Yeah, so great thing to play around with, as with all these episodes. I'll include a link in this one. Like I said, I'll include a link to this Git copy, and in order to run it, you will need to fill in this information if you want to play around with this. Alternatively, if you don't want to do that, then what you could do is just use all local copies of stuff, and if you correctly fill this in, as you can see here, these pairs here, these key value pairs, then it won't even attempt to run the URL one. So yeah, that's another way of doing it if you don't want to be messing around with any of this information. But from a technical perspective, it is worthwhile trying to pull stuff from the web, but as always, just be respectful of the content and use the correct procedures, and then you won't get into any problems. Thanks once again for watching. Bye for now, and I will catch you in a future episode.